Alright, welcome back to another Roblox programming tutorial, and today we are discussing the fundamental concepts behind object-oriented programming, or OOP as it is known by most programmers. Now, object-oriented programming is a pragma, I think that's how you say that word, or a style, or a way to program, right? That's more of what it is. It's not anything new that you're learning. It's just a way to organize your code and program so that things are as flexible as humanly possible. And that is the whole goal behind object-oriented programming. So let's first go ahead and look at procedural programming. Procedural programming is what you all are most accustomed to. That is when you jump into a script, right? And you go local part is equal to the script dot parent, and you create a script. So like part dot touched colon connect function boom, and we'll go for c equal to 1 to 10 do, excuse me, misspelled do here, part dot transparency is equal to c divided by 10, and then at the end you'll do parts dot can collide to false, and you'll wait 3, and then you'll do like parts dot transparency equal to 0, and then you'll do parts dot can collide equal to true, and then we'll probably need a debounce, so debounce true if debounce, then all of this wait 1 debounce is equal to true, and here we need debounce is false, and then we need an else return. Cool. So if you have no idea what I just typed in, or are looking at this like, oh my god, I've never seen anything like this before in my life, and I need to enter, then all I've done here is I just created a program that makes a block fade on touch, right? And this is a good example of just, you know, how just a very simple program that just, you know, does something that we're really fundamentally accustomed to. I also need to put a wait here of like 1/100 of a second, so there's like a little delay time here. Okay, so very standard program. Again, I think this was on the first part here, perfect. So if I go ahead and jump on this, it should fade pretty quickly, assuming I didn't mess anything up. Oh, I forgot to anchor it. Right, good example here. Parts not anchored is true. Right, all right, so anyways, I go ahead and play here, and this is a good example of procedural programming again. Now I jump on this part, it fades, and I fall. Perfect. That is procedural programming. And while that is great, it will only get you so far, because what happens is again, the storage, or the way things are stored, is they're all stored in this individual script here, right? And what happens is even if you use, you know, collection service, which we haven't talked about yet, but is a way to kind of embed, you know, object-oriented programming somewhat into your scripts, or reusability somewhat. The problem is that organization for this now becomes a disaster, because if you wanted to, you know, keep track of this script and all the times you're using it throughout a game, right? And then that doesn't even mention refactoring, right? So like number one, let's say I wanted to create a Spleef game. Here's all the instances that I've now created the script, right? And on top of that, Roblox Studio now has to read all the lines in all of those scripts. So let's see how many lines this was. Let's say, you know, it's theoretically production, right, where you don't have all these extra lines. You have some program that gets rid of all these lines. So you have 18 lines of code. So we have to read 18 times what? However many I've selected here, which is a ton of lines of code, right? So from a production standpoint, the game has to read way more stuff, because essentially it doesn't, like, there's no reusability here. Every time the script is called, the game must read all of that stuff. Now, the idea is that you want to eventually get away from programming in this way, and you want to eventually get to a point where this, instead of being encapsulated here, is encapsulated inside of a module script. Okay, so let's go ahead and do the exact same program now, but I'm going to go ahead and do this inside of a module script. So we'll go ahead, create another function here. We'll call this function. We have to store it inside the module script function. Dot fade. Okay. And click enter, and then inside of here, I'm going to paste all of this code, right? And I can go ahead and do like a local bounce here to keep that in here, and I need to pass the part parameter. All right, cool. So I now have this stored inside of here. Now, Roblox Studio only has to read this one time inside of the module script, and here all it has to read is the path. So if I do my functions, right, is equal to require game dot server storage dot my functions. Now it only has to read what, 3 lines of code, my functions dot fade, and then parts. Look at that, 3 lines of code versus the 18 from before. This is again what makes module scripts so flexible, is this right here. Now when you're building big massive games, this really matters, because if you're programming all this stuff, the more lines of code you have, the more stuff that Roblox has to read, the slower your games are going to be, which is why you want things done modularly, because now it only has to read this function one time inside of the module script, right? So this is the whole idea behind why you want to switch more towards an object-oriented programming versus a procedural programming. Things are easier to refactor, things are much well organized. From a performance standpoint, it's better. And I could go on and on about why object-oriented programming is, the standard, but this is more of a video on what it is, right? So this is the reasons why you would use it. Now let's talk about what object-oriented programming is. Object-oriented programming is a way to program, a pragma, I think that's how you say that word, but it's a style of programming, right? Where essentially you have storage centers for classes. A class is a template of an object, right? So let's go ahead. I'm just going to create an example module script here. We'll call this example, and let's go ahead and talk here about what object-oriented programming is and an example. Okay, so I'm going to go ahead and rename this as example as well. All right, so you have 2 things in object-oriented programming. You have classes. Classes are templates for objects, and then objects are the instances of those classes. Now, that might sound like a lot of words that I just said, but let's look at an example. Let's say I had a dog. So inside of this example here, I wanted to create a dog. So function, or excuse me, yep, no, function was correct, my bad, function. So this function is going to create a dog. Example, dog. Okay. Now, what do I want this dog to look like? Well, I want the dog probably to have brown hair. So like dog's color is going to be a color3.new, where the dog has brown hair. So I'd go ahead and I'd find brown here. Or I can't find brown. Which one of these is brown? It's like this kind of colorish. Pretend that's a great looking brown here. It's not brown, but that's okay, right? But this is a good example, right? And then, you can change things about this dog and change a whole bunch of stuff about this dog, right? So you can change the dog's color, you can change a whole bunch of stuff. Now, this is highlighted in red. We'll talk about this in a second, right? But you can also program, as you've seen in module scripts, behaviors of the dog, right? For example, when the dog is touched, maybe you're petting the dog. When the dog is touched, you can connect a function to happen. Right? So dog, or you can print now, arf, or woof, right? So this right here is an example of a class dog. When I call this function into a part, that part is the object. So let's look here at the fade block again. This is the class of a fade block, right? Where I created properties for the fade block. right? And I can also change other things about this property, right? So I can change the transparency initially to be not transparent. I can make part dot, color a specific color. Right, so now I have it red. Right, so these are all the properties that define the class, right? So this is that define a fade block, and then these are the behaviors right here. These are the behaviors. In object-oriented programming, objects are defined by their attributes, which are these, their properties, what they look like, and then their behaviors is how they act. So this would be an example of a class. This class is considered to be a fade block, right? And I named it fade, right? So this is class fade. And then when I call this into this script, this part inside my game is an example of that object, right? So this part, wherever I called it in, I think, which script has this underneath it? The fade script. I think they're all named fade. Okay, so this part right here. So this is the object that has it. So this would be an example of the object of that class, right? Where this will inherit all the properties and behaviors of this class. This is the idea of object-oriented programming, right? Objects, again, are defined by their attributes and their behaviors, where the attributes are all of its properties, as we know, and then their behaviors are all the functionality, right? And it's all stored in one place. And then when you want to create a new instance of that, you put it right here. So again, this is a good example of object-oriented programming. This would be an instance of a fade block. So that's the basic concept. So back here to my dog example, right? I want to come back to this keyword of self. This is a hard concept to understand, but very necessary. Whenever you create a new instance of a class, and you use the self variable in programming, self refers to whatever is calling this. So instead of writing dog here, it doesn't know what dog is. It's very confused. It's like, what is dog? You would use self. This is how the self variable is used in object-oriented programming. So now, in the example, I have a dog class where the dog's color is this, and when it's touched, it prints woof, right? So let me go ahead and create a part. So here's a part, and I probably also want to anchor this part so the self does not fall. So now whatever's calling this function, self, its anchored property is going to be true. Okay, now here's my dog part right here. We can change this to blue so you guys can see that it will not be blue when I run this script. Now I'm going to create a new script under this, and we're going to call in that dog class. So we're going to call this my functions, or its example is equal to game require. So this is the path, require game server storage example. Then in here, I can create a new instance of that dog class, right? So I'm gonna go and I'm gonna go example dog, and I'm gonna pass what I want to make the dog. In this case, it's the script parent. This makes this part a new instance of this class where self is used. This is the idea. So now this dog, or this block here, right, will be brown-ish in hair color. I did my best with brown hair, guys. Gray-ish. He's gonna have black fur. Never mind. He has black fur now. Gray or black fur, and then when you touch it, he says woof. So let's go ahead and look. So I'm gonna go ahead and play here. Woof. As you can see, he says woof, and his hair is black. And this is the whole idea behind object-oriented programming. Okay? So in the next video, we're going to talk about encapsulation, polymorphism, abstraction, and some other concepts related to object-oriented programming that are super important, but that'll be in the next video. Again, this is a very somewhat of a complicated topic, so if it didn't make any sense or you feel really confused, don't worry. Using the self variable does take some time to understand, so I'm completely right there with you. If you have any questions, please feel free to leave a comment, and I will see you in the next one.